Another imaging technique is imaging by the refraction, which can be applied for the thick lens and the thin lens as well. Okay, so here we have the object in the medium 1 with refractive index equal to the n1. Okay, so right now I just want to conserve the number 1 for the size that we have the incident light. Okay, and then if we have another medium, so let's say that it's to be the medium 2. Okay, medium 2, and then this medium 2, right, is going to form the spherical surface here with the radius of the curvature equal to the r. Okay, so let's say that this is going to be the r, the radius of the curvature. So this will be the distance from the vertex and then to the center of the curvature, right? And refractive index of this medium 2 equal to the n2. Okay, so now for this number 2, it's going to be conserved for the refracted light. Okay, the refracted light. Okay, so now in this case, if we just want to consider the sign of the S, the R, and the S palm, right? So we need to look at the one which is related to the refraction. So it's going to be for the lens, right? Because the lens here is just related to the refraction. Okay. Okay. Now we just want to find the position of the image, okay, by the ray diagram. So the idea is we just draw only the 2 light rays, and it will be enough to find the position of the image here. The first one is going to be the one which is passing through the center of the curvature. Okay, so why is that? Because, okay, if we have the light coming from the object, right, and now if this part is just passing through the center of the curvature, it means that this incident light must be perpendicular to this interface. Okay, so then some parts of the light will be reflected back to its original path, and then some parts of the light will be transmitted through this interface. Okay, and then just going to this medium 2. Okay, the other one, right? So let's consider the light just coming from the head of the object and then come to the vertex point here. Okay, so now you can see that, so this is going to be the interface, right, between the medium 1 and the medium 2. So now some parts of the light will be reflected back, but we are not taking into account this one, right? But we considering the one which is inside the medium 2 here. Okay, so you can see that we have some oblique incident. Okay, so it means that the light coming to the medium 2, right, is gonna refract with some angle. Okay, so it means that actually if we know this is angle, if we know this refractive index, right, then we can just solve for this angle. Okay, but right now I'm just randomly draw the arrows. So this can be the refracted light. So you can see that this is gonna form the image here. Okay, so here we can have the final image. Okay, so then finally we can get that this distance, right, this distance is going to be the image distance, the S palm. Okay, for the image distance. Okay, actually we have equations that we can use to solve for the object distance, the image distance, and the radius of the curvature. Okay, and also we can find the lateral magnification. Okay, the equation is here. Then again, I will not derive this question, okay, but I mean to solve this question we can just simply use the trigonometry, okay, but I mean the point of this is we just only use this equation to find the image and that would be enough. Okay, don't forget that the number 1 and number 2, right, for the medium for the incident light and the refracted light respectively, okay. And the size of the S palm and the R, right? So the size of them must follow the size convention that I just mentioned earlier here. And now for the lateral magnification, right? It's just equal to the Y palm over the Y. So the Y is going to be the height of the object, right? This height, this will be the Y. And the Y palm is going to be the height of the image, okay? So this will be the Y palm here. And then equal to negative of the N1 over the N2 and the S palm over the S. Okay, so then again, the sign of the M, right, and the Y palm and the Y, it just follow this these sentences, okay, these conditions. Okay, so let's look at these figures first. By the way, so this P is just the S, the object distance, and the I here is with the S palm for the image distance, and the R is to be our capital R, which is the radius of the curvature, okay? Okay, so now from this picture, let's consider the size. The object is here, right? And then this going to be the medium 2, okay? So in this case, the S must be positive, right? Because we say that the object distance, right, is going to be the positive when the object is on the same side as the incident ray, okay? So then in this case, you can see that the object is on the left hand side of this interface, and then the incident ray, right, just on the left hand side as well. So that's why this must be positive, okay? So let's just write down. So in this case, the S must be positive. And then how about the I, right, which is the S palm in our case? So now again, we need to look at the refraction by the lens, right? In this case, we say that if image distance is going to be positive, if and only if the image is on the same side as the refracted ray, okay? Because right now we're talking about the refraction, okay? So we need to look at this one. So S palm is positive when the object is on the same side as the refracted ray. So then in this case, you can see that the image is on the right hand side of this interface, right? And now this refracted ray is on the right hand side of the interface as well. Sorry, I just made the wrong picture. Okay, so the image is on the right hand side, okay, and the refracted ray is on the right hand side as well. So in this case, we can get that the S palm is positive, okay. And then how about the radius of the curvature? Okay, so it's just the same as the S palm, right? So the radius of the curvature will be greater than 0 if and only if the radius of the center of the curvature is on the same side as the refracted ray, okay? Then in this case, we have the radius of the curvature and the center of the curvature is on the right hand side of this interface, okay? And also the refracted ray is on the right hand side of this interface as well. So it means that this R must be greater than 0. Okay. Okay, so let's look at this one. Okay, so let's look at this one. Now, we have this interface, okay, medium N1 and medium N2. So you can see that the object, right, is on the left hand side, and the incident ray is on the left hand side as well. So in this case, the s must be greater than 0. Okay, the s just greater than 0. Now for the image, right? The image is from here. Okay, image is from here. But now we say that, okay, so let's look at the sign convention. We say that if the image is on the opposite side as the refracted ray, okay, so we get the virtual image and the s palm is less than 0. So now in this case, right, you just see that the image is on the left hand side of this interface, but now the refracted ray is on the right hand side, right? It means that this image and this refracted ray are on the opposite side of each other. So it means that this image is going to be the virtual image, and then the s palm, right, it's just less than 0. Okay, so now finally for the radius of the curvature. Okay, so from this picture you can see that the center of the curvature is on the left hand side, right, but now the refracted ray is on the right hand side. Then if we look at the sign convention, right, we said that if the radius of the curvature is on the opposite side as the refracted ray, so it means that the r will be less than 0. Okay, then in this case, right, we have that the r should be less than 0. Okay, so this will be some, example that you can see about the sign convention. Okay, so let's look at this example about a thick lens. Okay, about the thick lens. So we can use the idea of image formation by refraction on the spherical surface, right, to find the image due to the thick lens. Okay, what is the thick lens? The thick lens is middle length, right? But now the thickness cannot be negligible. Okay, so for example, in this case, we have the lens with the thickness equal to the 10 centimeter. Okay, when we talk about the thickness of the lens, right? So it should be the distance from one vertex to another vertex here. Okay, so now from this picture, we have the object on the left hand side of this interface, right? And now the distance from the object to this vertex equal to the x centimeter. Radius of the curvature equal to the 2 centimeter here. And now the length of the lens equal to the 10 centimeter. So then another spherical surface, right? We have the radius of the curvature equal to the 2 centimeter as well, the same as the previous one. Okay, so now we just want to find the position and the total magnification of the final image. Okay, to find the final image, you can see that we can have the two refraction. Okay, so now the first one is to be the light which is refract on this interface, right, and then come to this medium, and then after that this light will be refract again to this interface. Okay, and then to form the image somewhere. Okay, so it means that we have the two steps, okay, to solve for this one. The first step is to consider the left hand side interface, and now the second step is to consider the right hand side interface. Okay, so consider the left hand side interface, right? Okay, so let me just copy this question first, and then we can see which variable we need. Okay, so let's just start from the N1, right? So don't forget that number 1 here is preserved for the medium which is on the same side as the incident light. Okay, so now in this case the object is here, and we say that the object will emit the light. Okay, it means that in this case the incident light will be on the left hand side of this interface, right? Okay, so it means that the N1 must be equal to 1 for the air. Okay, so we have the air here. And now for the N2, number 2 here is conserved for the medium which have the refracted light. So it means that the light coming from here and then reflect to this medium, right? So the N2 must be equal to the 1.5. The R, the radius of the curvature. In this case, the center of the curvature is this position, right? And also it's on the same side as the refracted ray, okay? Because light coming from here and reflect, okay? So it means that the refracted ray is on the right hand side and the center of the curvature is on the right hand side as well. It means that the R must be positive, right? The 2.0 centimeter, that's be the R. The S, the object distance, is just clearly, right, equal to the x centimeter. And then we just want to find the S palm, the image distance in this case, okay? Because when we find the S palm, we can find the position of the image, I mean from the first interface, right? So this image is going to be the object for the second interface here, okay? Okay, let's use equation the N1 over the S plus the N2 over the S palm, right, equal to the N2 minus the N1 and then over the R. Plug in the number. We have 1 over the S, the 8.0 centimeter, okay, plus the N2 just the 1.5 and then over the S palm. So we just want to find the S palm equal to the 1.5 minus 1 and then over the R. The R just the 2.0, okay? So then finally we can get that the S palm is equal to plus 12 centimeter, okay? This will be the S palm. And then how about the lateral modification, right? So let's find the M. The modification on the left hand side, let's say the LHS for the left hand side, equal to minus, right, N1 over the N2 times the S palm over the S equal to N1 just equal to 1 and the N2 equal to the 1.5, the S palm 12 centimeter, and now for the S, okay, equal to the 8.0. Then we can have that the lateral modification equal to minus the 1.0. Okay. So now let's interpret these numbers. Okay. The first of all, let's consider the S palm here. The S palm equal to the 12 centimeter, okay? It means that the image, right, must be on the same side as the refracted ray, okay? So if we only consider this interface, okay, so let's just ignore this part. So let me just ignore this. Okay, let me just ignore this one. So we say that the image, right, it should be on the same side as the refracted ray on the first interface here. The refracted ray is on the right hand side because the light coming here, this will be the incident light and then reflect into this direction, okay? So this will be the refracted ray, okay? So then we can get that the S palm equal to the 12 centimeter. So this will be the distance from the vertex, right, equal to the 12 centimeter. Then we said that this distance equal to the 10 and the radius of this one, right, equal to 2, so 12 should be here, okay? So then this is going to be the position of the image, okay, 12 centimeter from this vertex of the first interface here. And then again, S palm is positive. It means that this image is the real image. I mean by by the first interface. But don't forget that this is not the final image. Okay, this is not the final image here. Then for the m, right, equal to the negative 1.0, we have the m equal to the minus 1. Okay, it means that the image will have the same size as the object. Okay, because the magnitude of the m equal to 1, so the image we have size the same as the object. But now this negative sign just means that the image is inverted. Okay, because if the object is pointing in the upward direction, so the image here will just point in the downward direction. Okay, so let's say that this is going to be the intermediate image, right, formed by the left hand side in surface. Okay, so let's see, you can see that the length of this arrow just the same as the object here. Okay, now let's consider the right hand side interface. So let's move this one back. Okay, this is the image, right? But let's see, this is the interface between the two mediums here. Okay, the light, the reflected light, from this interface is going to be the incident light on this interface. Okay, so in this case you can see that the incident light is on the left hand side of this interface. Okay, but we said that this image, right, from the first interface is going to be the object for the second interface. Okay, but now this object is on the right hand side of this interface. So we said that from the sign convention, right, we said that if the object is on the opposite side as the incident ray, it means that we have the virtual object and the s is less than the 0. Okay, so just be careful about this one. Then in this case, the image from the left hand side interface, right, is going to be the virtual object for this interface. Okay, because the incident light just come from the left hand side, but the object is on the right hand side. Okay, and that's it. So now you have known what the meaning of the virtual object already. Okay, so let's just write down. We have the s, okay, equal to minus, okay, the virtual object, so the s must be negative, right? So this distance equal to the 2 centimeter, right, because this is 12 and this is 10, so this must be 2. So we have the s equal to the negative 2.0 centimeter. Okay, let's just put it here first. Now for the n1, okay, so don't forget that the number 1 is preserved for the medium which is on the same side as the incident ray. Okay, so in this case the incident ray is on the left hand side of this interface. Okay, so it means that the n1 equal to the 1.5. Now for the n2, right, for the n2 here, number 2 is preserved for the medium which is on the same side as the refracted ray. So you can see that if we have the light coming from here, right, it will be refracted to this medium. Okay, so it means that the medium 2 is the air. Okay, it's the air. So we can get that the n2 equal to 1, right? But now for the r, the radius of the curvature. Okay, this is center of the curvature of the second interface and is on the same side as the refracted ray as well, right? This is the refracted ray. This is the center of the curvature. Okay, it means that the radius of the curvature must be positive, right? So we have the r to be positive, so it's just equal to the plus, and the 2.0 centimeter. Okay, and we have this S already, and we just want to find the S palm. Then we just follow the same equation, right? We have this one. N1 just the 1.5 over the S. S is negative 2.0 plus the N2 equal to 1. And then over the S palm, right? So we just want to find the S palm equal to N2 minus N1. So we have 1 minus the 1.5 and then over the R just 2.0. Okay. So now we just solve for the S palm. So let me just skip this part. We can get that the S palm here, right? It's going to be equal to the 2.0 centimeter. Okay. And then how about the lateral magnification on the right hand side? Okay, on the right hand side. Then from the equation, right, equal to this one equal to, okay, minus N1 just 1.5 into equal to the 1. S palm 2.0 and the S is negative 2.0, right? And then equal to plus the 1.5 here. Okay, it's not done yet, but I mean, let me stop here first. So let's consider this one, the S palm, right? The S palm is going to be the image formed by the second interface here, and also it's going to be the position of the final image. Okay, we have the S palm to be the positive, right, equal to the 2.0 centimeter here. So now from the side convention, it said that if the S palm is positive, it means that we have the real image, and the image is on the same side as the refracted ray. Okay, so then in this case, we have, this is the incident ray, right, for the second interface here, and this will be the refracted ray. Okay, it means that this image must be on the right hand side of this interface, the 2 centimeter from the vertex, right? We should be this position again. Okay, this position again. So this position will be the position of the final image. Okay, now we get the lateral magnification, I mean, for the right hand side interface, right, to be equal to the 1.5. Okay, but we said that we just want to find the total lateral magnification. Okay, we just want to find the total lateral magnification. So let's say it's equal to the m, right? What equal to the m. So what is the m? This m is going to be the multiplication of the m left hand side and the m of the right hand side. Okay, so why say that? Okay, it just simply explained by this. So let's say that if the m, right, left hand side equal to, I don't know, the y palm over the y. Okay, so it's going to be the length of the image relative to the length of the object, right? And now the m of the right hand side equal to the y palm and then over the y palm. So the y palm here is going to be, I mean, the height of the image. This is going to be the object for the right hand side. Okay, and the y palm is going to be the height of the image due to this right hand side. Okay, so then totally we just want to find what? We just want to find the total magnification. Okay, so we just want to find the ratio of, I mean, the height of the final image and then over the height of the original object. Okay, so it's going to be equal to the m of the left hand side times the m of the right hand side, right? Because this one equal to the y palm over the y and then times the y palm over the y palm. So this y palm just cancel out, right? So we have the y palm over the y, which is the total lateral magnification here. Okay, equal to, okay, so let's just put in the number. LHS, this one, right, equal to the minus the 1.0, and here this one equal to the 1.5, which is equal to minus the 1.5. Okay, so this will be the answer, and also for this one, right? Okay, so then for the conclusion, this image is inverted, okay, relative to the original object. Okay, and then the length, the height of this image is to be the 1.5 times of the height of the object. So you can see that if let me move it here. Okay, so now so now if the object is rotated in the upward direction, right? So in this case, we can have the image, the final image, right? It will be rotated in the downward direction, and then with the height, it's going to be the 1.5 times of the original height of the object. Okay. So this is going to be the final image, right? And then we can conclude that the final image is on the right hand side, okay, of the second interface. Okay, and the image is going to be real. Okay, it's going to be the real image because the s-palm is positive, right? And image is real, inverted, okay, and enlarged, right? Because we have this negative sign, so it means that the image is inverted compared to the original object, and enlarged because this number is greater than 1.